Okay, when we're dealing with an absolute value graph or absolute value function, you know what gives it away that's an absolute value function? It has absolute value symbols. Okay, so right here, this is the most basic one you can get. This is the most basic one you can get, and you get varieties of these functions. So let's start with the most basic one. What I want you to do is pick okay, I'm going to pick it for you, but you usually pick 0 and then a couple positive, a couple negative. Oops, that's positive, and I'll just make it clear. For the x values, remember x are independent, so you can pick any numbers for x. Then you can find your y. Fill in the y column, and I want to see if you guys remember, okay, if x equals -2, the absolute value of -2 is 2. So fill it in. Don't say it, just fill it in. And then get your table set up. And do you guys remember what I said about the shape of this graph? So we're eventually going to get to the graphing part. It's going to be a V, okay? It's a V graph.
Wait, do we have to do this?
Yeah. Yes. Good question. Yes. And the V graph, guys, the reason I haven't gone through this in Algebra 1 before. This is my first time going through it in Algebra 1. The reason why I go through a V graph is because in like 3-4 months we're going to go over a U graph. Okay, it's a parabola, and that parabola is going to be a lot easier because you've already kind of done it with the absolute value V graph. Parabola, it's like, okay, basketball. You know how they say the arc of the shot? That's traveling in a parabola. You shoot it up in the air, and it travels like that. It can go sometimes a lot higher. It can go a little bit flatter, but it's always going to travel in that parabolic direction. Okay, anyway.
Wait, Mr. Wright, is there a W graph?
Well, you could say like two absolute values together, but there's no like W graph. Okay, here I got 1, 0, 1, 2. You guys okay with that? Do you guys notice that my Y values in this table are never going to be negative, right? Okay, that gives us a hint to when I put my graph, none of my Y values will be negative. Okay, so what I want you to do now is go ahead and get me a sketch. We're going through a lot. I'm splitting this up into 2 lessons. So today we'll do part of it. Tomorrow morning we'll do another part. And then in the afternoon we'll review for the test. 1, 2, 3, 4.
Why are we reviewing? Wait, what day is
Friday.
No, what days are we reviewing?
Wednesday afternoon and Thursday. And then Friday you take it. Because there's no review time. Can you guys put these points on the graph? So -2, 2. So -2, +2. -1, +1. 0, 0. 1, 1. 2, 2. And do you guys see it already? Do you guys see that shape naturally coming about from that table? And so go ahead and connect them.
Do we connect them in 0?
Yes, 0 is a special point in this graph, and we'll start labeling those points, those parts.
All of them are going to have to mirror?
Pretty much, yeah, because if you did the absolute value of -5, that's 5, so you'd go -5, 5. And the absolute value of +5 is also 5, so it's always going to be a mirror image of itself. Okay, you guys got that graph? We gotta label some parts of the graph though. Here are the 5 things we're going to have to know from this graph. 5 things. I'm going to list them out and then we'll actually write them out. The word vertex. Sorry?
Is it always going to be a perfect V?
Yes.
Like right angle and everything?
Do one side.
So what if you...
Technically you can, but it does get shifted, and later on it's going to get compressed, it's going to get widened out. So, but that's later. Next 2 years from now. For most of you. Yeah. But you will get that. It will come. All right. We also need to know the axis of symmetry. The axis of symmetry. You're like, what? Well, do you remember what symmetry is all about? Symmetry. Think symmetry. Can you guys give me an example of God's creation symmetry? Your face. It's pretty symmetrical. Now, some of you are like, no, it's not, Mr. I've looked in the mirror and it's not symmetrical. I just know it. Okay, but normally it is. I think of a butterfly. Okay, you guys know butterflies. Do you see how if you put a line, an axis of symmetry, through that butterfly, right through the middle, you would get a mirror image, right? One wing, the other wing, it'd be just folded in, same image. That's what we're talking about, axis of symmetry. We'll get to that more. Mister, it's not. Okay. X and Y intercepts. You guys know that already, right? Do you guys remember X and Y intercepts?
Yes.
What does an X intercept mean? It's where my graph hits the
X.
x-axis. What's a y-intercept? Where it hits a y-intercept. So that's not new, but it is going to be sometimes different. And then, because I don't have enough room, I'm going to put one here. You're going to have to know the domain. That's the possible set of x values. And then guess what the fifth thing is? Range. So I know it's on the same line, but these are different. And range is the possible set of y values. Okay? So write those down. We're going to go through it.
It's like all review.
It is, yeah, basically all review. So you're putting it all together. Okay, let's look at the vertex first. Okay, you guys have that graph. Where do those two lines meet together? Because don't you see the two lines? And it's really, I guess it's a ray, but those rays, where do they both meet? Close. 0, 0. Yep. The vertex on that first graph is 0, 0. It's where those two lines meet. By the way, one line is a negatively sloped line, isn't it? And then the other one is a positively sloped line. So they both meet at the vertex. Axis of symmetry. This one's a little bit tough at first, but then you guys get it.
Graphing.
Uh-huh.
Couldn't we just draw a V and then it would be right?
Well, remember what I said? So here's where the graph is right now, but it could be like this, like this, like this, like this. So it could be anywhere.
So
It doesn't have to start at the 0, 0. This one does, the most basic one.
This slope's always going to be 1, the absolute value.
For our graphs, yes, they're going to be down 1, over 1, so negative 1 and positive 1, but it can switch up later. So we're looking at basic. All right, axis of symmetry, guys, is always going to look like this. X equals something. X equals something. Ooh, let's see if you can do this. Okay. The axis of symmetry is a line. Okay? It's a line. Looking at my graph, what line splits this absolute value graph in half symmetrically? X equals what?
0.
Oh, that's it. Okay, ready, guys? If I told you to graph, listen. If I told you to graph x equals 0, do you guys understand that's a vertical line? X equals 0? Okay, and it's right here. And I'll do it in, I guess I'll do it in a different color. It's right here. This is where x equals 0. This line right here, which happens to be the y-axis. Does it split this in half? Are these mirror images of each other? That is the axis of symmetry. Oh man, I lost the color. So that's that one, maybe? X equal, oh.
Is this just your favorite stuff, Mr.?
It's getting there.
What's your favorite?
Yeah. Okay, that's kind of, we'll let that slide. All right, we'll let it go. If you see different colors, something's wrong with your eyes. All right, anyway.
If you see different colors, you're special. That's used to videos.
Wait, are those different colors?
Yes, they're similar.
Excuse me? All right, then we're going to look at the X intercept. The X intercept and the Y intercept. Okay, do you, excuse me. Do you remember what X intercept meant? It's where the graph hits the x-axis. When you're looking at the graph, where does this graph hit this x-axis? At 0, right? So the x-intercept would be
0.
okay. X-intercept is 0.
Y would be 0 too.
And in this case, the y-intercept, if you're looking back at the graph, the y-intercept, where does it hit the y-axis? It also hits it at 0. And again, most basic graph, very easy to find out. Okay, so you have those. So we have the intercepts, and then domain. Ooh. This is where it gets a little tough here because they're technically, well, it's not technically, but it could be tough. All right.
Wait.
Look at the,
Domain and range just be 0, 0?
No. The domain are what are the possible x values, and you have to write it in one of our favorite forms.
Bracket. Or
No, sorry,
Set builder notation.
not set builder, because that takes interval notation. Yep, interval notation. All right, look at the graph, guys. Do you guys see that this arrow would continue? I mean, this line would continue going, right? Infinitely, infinitely. All right. What are the possible x values? What can possible x values be?
Infinity and negative infinity.
All right, it's anything from negative infinity to positive infinity. Yep, that's the domain. It's anything,
No
right?
bracket or anything?
No, because of it's going to keep going. When you have infinity, parenthesis. If it's infinity this way, parenthesis. So never put parenthesis with a bracket, because you're restricting infinity, which is like impossible.
There would be one where there is bracket.
What a great question. Okay, let's look at the range. What are the possible y values? Like, look where it stops, where the graph, remember the v stops.
At 0.
Right there. Doesn't it stop right there? Can y be anything that's negative?
No.
No. So here's what I would do. It starts at 0 and goes into positive infinity.
Zero, would it be zero infinity?
Oh, oops, and I almost messed that up. Bracket 0, positive infinity, parenthesis. That's the range. It starts at 0, and it's a closed circle at 0, and it goes into infinity, positive infinity.
Okay, how do I know if it's close circle?
They're almost all going to be closed circles on where they start, because there's a closed circle right here. 0, 0 has a dot, and it's filled in, closed. You will get this in 2 years. It's going to be an open circle, and then you'd have to put a little parenthesis, but we're not going to get that detail.
What does it mean? Put the line dash.
Oh no, we're not dashed right now on this. So these aren't inequalities yet. Okay, yes.
What does that mean if it's an open circle?
That the graph does not hit 0, 0, but it's everything past that, before and after. Okay. All right, you guys see where we got these different parts? How many of you, yes, there are 5 parts, but you know pretty much what all 5 are. You know what the vertex is now. That might have been you. The axis of symmetry is always a vertical line. The x and y intercepts, the domain and the range, right? You've kind of done this before. We're putting it all together. This is our new lesson today. But that was the most
Easy.
basic graph.
So they're doing
Wait, I think you got basic and complex.
Oh. Then let me give you a very easy graph. Let's go with another one here. Y equals, so this is a separate graph, negative absolute value of x.
So it's just going to be a number.
It's still going to maintain its V shape. It will maintain its V shape, but it will not look the same. It will not be the same as the previous graph. I hope you can tell by just the numbers. Go ahead, guys, give me a table. You won't have to do a table for long. We're going to figure out how to do this without
How many points do we need?
5. 1, 2, 3, 4. I don't like that line. Da-da-da. Uh-oh. 1, 2, 3, 4, 5. Okay, I'll go with that. You got your x and your y. So I'm going to go 0, -1, -2, 1, and 2. Figure out those values. Please be careful.
There's this thing as negative
No.
0.
Well, it is -0, but -0 and +0 are the same.
So
Just
we
0.
say negative 0.
I'm going to cringe a little bit and then say, yeah.
Anything with 6 plus 0, can we write 6 minus or plus negative 0?
Yeah.
What would you say if
I
you
think,
wrote 6
I'm
minus
gonna
0?
do that.
All right, anyway, what's the absolute value of -2? Absolute value of -2?
Negative
2, but the opposite of that would be -2. What's the absolute value of -1? 1. What's the opposite of that? -1. That's 0. What's absolute value of 1? 1. Opposite of that, negative 1. Negative 2. All right, go ahead and plot them on a graph. Go like 4 by 4 by 4 by 4. 4 by 4 by 4. And graph them.
Upside down. Go down to wait, we graph them down.
Yes, please.
All of them?
Yes. Some of you are already starting to pick up patterns. You're starting to say, oh, wait, isn't this? Yep. Isn't that? Maybe. Isn't that? Nope. So you have different patterns in your mind. We'll see if we can pull them out. All right, I'm going to put these points where they belong. Negative 2. Make sure I do it right. Negative 2, negative 2. Negative 1, negative 1. 0, 0. 1, negative 1. 2, negative 2. And if I connect them, whoa, it's like upside down. That's an absolute value graph that got reflected. Oh, that's a geometrical term. You're going to hear it again. Do you hear what I said? It was this, the original, we call it the parent graph, like the original absolute value graph. And then it gets reflected on the x-axis. I'm just throwing out words. You're like, that sounds so weird. Well, get used to it because you will see it that next year. Okay, but anyway, do you guys get this graph? You guys okay with that graph? All right, get me the 5 parts from the previous, like I did for the previous. I want the vertex. I want the axis of symmetry. I want the x and y intercepts. I want the domain. I want the range. And I want it now.
Isn't there technically 6?
Yeah, if you want to say x and y or 2 separate ones, fine. But let's make it 5. And let's make it 4. Domain and range is 1.
And X and Y intercepts.
Yeah, I would just say that's 1. Yes, ma'am?
Is the vertex always going to be in the middle of your table, or are we still not do this?
You're not going to do this, and it doesn't have to be, because I could have picked 3 and 2 positives, 3 negatives, and it would have been off center. Or I mixed it around, so yeah, it doesn't have to be.
Instead of writing axis of symmetry, can we just write like A of S or something?
Say what?
Instead of writing axis of symmetry, can we write like A of S or something?
You could say axis of sym.
Okay.
S-Y-M period. All right, so here we got, you're going to give me the vertex, which is always an ordered pair. You're going to give me the axis of symmetry, which is x equals something. The X intercept, the Y intercept, the domain, and the range. Uh-huh. Oh. Ranger, huh? It's the vertical line that splits that graph in half. Perfectly symmetrical. The axis of symmetry. And in this case, yes, it's pretty nice. Yes, sir.
How do you find the vertex?
Yeah, you just look at where, so you see this positive line and this negative line? Where do they meet? What point do they meet at?
0.
Finish that. 0, 0, 0. Like the point right here? Is that the point? So we call it 0, 0. That's the vertex. Okay, the axis of symmetry. What line splits that in half?
0.
X equals 0. And it has to be a line, so you say x equals 0. All right, X intercept. Wow. Y intercept. Oh. The domain.
0.
Okay, sorry. So you have your x values. What are the possible x values?
Negative infinity.
Parenthesis, negative infinity, comma, positive infinity, parenthesis. And then your range. Okay,
Bracket.
say that again.
Parentheses, negative infinity,
Oh, bracket.
0, bracket.
Yeah.
These are
Yeah.
the only answers you
Elijah
get
from
from
mathematician.
graph.
No, we're going to get more complicated. Yeah, so far, we've dealt with two graphs, and then we're going to get more. Yeah, yeah.
For the range, I did like
That's okay. Notice I said, okay. So here's what I'll do. If you ever have negative infinity, it should come first.
Okay.
So just switch it up next time. All right. Guys, okay with that? Yes, ma'am?
Well, how do you know, like, with the range, how do you know, like, whether to put 0 or negative infinity first?
Because whenever you start with, like I was telling Gracie, if you say negative infinity, that has to come first. Because negative infinity is coming either from the left side, so you're reading left to right, or you're reading from, in this case, from the bottom to the top.
Oh, so it's least to greatest.
Yeah, you can say least to greatest, but it's not wrong. Like, I'm not going to mark you wrong. I'll probably write on your paper the double-sided arrow and not mark it wrong, just to remind you. All right, let's go to another one. Actually, time out.
Will the domain always be infinity?
Say that one more time.
Will the domain always be infinity?
On most of these, yes, but it will change. I know I keep saying that, and I'm not going to give you that yet where it changes, but we looked at two graphs. If you have a graph in this form, there's something special about it. We say that the V graph opens upward. Opens upward. You're like, what are you talking about? Just do the V. Do the V in your mind, or you could do it with your hands. Isn't it opening upward? Isn't it like it starts down here and it opens upward? So if you have it in this other format, y equals negative absolute value of x, where does it open?
Downward.
Opens downward. So you say this one opens downward. That may not seem like a lot, but so again, I'm glad I get to do this. I get to tutor a few people, and they had to memorize absolute value graphs, square root graphs, square graphs, cubic graphs, linear graphs, rational graphs, and they have to know all of these parts. They need to know all of these. They just had to have these are memorized. Just all of them. Just got to know them all. And yes, you can memorize them, but sometimes you forget. But if you look at the graph, you're like, oh, yeah, it opens downward. Negative infinity, positive infinity, 0, negative infinity. So you can still figure it out, but eventually you're going to be required to know it all like that. Yes, sir?
Are there ever two absolute value graphs on the same plane? Like, could you have both?
Yeah, you can.
It's like the V.
Yes, you can have. I mean, I'm just sketching. Don't draw this. You could do like that. You could do like that. So that's your W.
Curve on the bottom. So
Yep.
it's like an X meter are actually two lines.
Would you have it like a diamond?
Or you could think of it as two lines like
Are
that,
they the same thing? Like if it's one line like that, one line like that, first one.
like that, and like that.
No.
Oh, like that, like that,
Yeah,
or like that, and like that, or like this way. Or sorry, got it. Oh, easy. Yeah.
like are they the same thing?
No, they are not the same thing. Okay, let's go through another one, then I'll let you go. I'm only gonna require half of this lesson because we're gonna have to go over this again. Okay, let's look at this. Y equals. So here's where it starts getting some writing. Y equals absolute value of x minus 2. Okay, so there's a lot more you can do to switch this up, but I'm just gonna do that. All right, before you even start doing anything, it opens upward. It has to open upward. Why does it have to open upward? There's a positive sign out there, not a negative, right? You know that. And you guys eventually will get to the point. This is really cool. Be encouraged. You don't have to make those tables. Eventually, you just look at the graph and say, I know where it starts, I know where it ends. Just look at it. But for now, we're going to have to do some other things. All right, let's go with the Vertex, Axis of Sim, the X Intercept, Y Intercept, domain. Not today, not tonight. You're just going to have to figure out the vertex tonight. You're welcome. Great question. Let's do it right now.
It's where the thing, it's basically Y intercept, right?
Not necessarily.
Because
This one's going to show us that. Watch.
then how do you find it?
Yeah, we're going to do it right now. Did we graph anything?
No.
Did we put a table for anything? but you still have enough info to figure out what the vertex is. Okay? And axis and all those other things. Okay. It opens upward, and then it has this little -2 going on here. Okay, to find the vertex, which is an ordered pair, I want to make sure.
0, -2. Yes.
0, -2.
Good stuff, Drew.
Okay, here's what sorry?
Yeah.
Okay, yeah, but sometimes it switches, like, if depending on what you do, it can be different, but in this case, yeah, but not always. Okay, here's how you figured it out. Ready? Please listen up. What you do to find your vertex is you take what are you going to be, how can you make this absolute value quantity equal to 0? What do you have to make x equal to make it equal to 0? It's 0, right? It's a 0. It switches up, so it's easy. So that's going to be your x coordinate. So how do I make this equal 0? Your y coordinate, you know how easy it is? It's just that number. So 0, -2, that's my vertex. That's it. No, because this isn't okay. It's 2, remember it's 2 lines, it's one going down, one going up. So I guess, yeah, but not technically, because it's 2 lines merged into one. So yeah.
Wait, does
Just to be
this
technical.
absolute value lines equal 2 lines?
Yes, you can say that. One positive, one negative. Either way. Okay, to find the axis of symmetry, all you have, this is even a cool part, ready? For the axis of symmetry, it's always whatever that number is. So what does x equal?
0.
That's it. It's like a domino. Once you find the first one, you got that one.
Symmetry is always 0.
So far. Yeah, because right now this is what this graph did. It went like that. You're going to see it just went like that. Sometimes it does that. Sometimes it does that and that, or that. And later on it's going to do that. That.
That's basically the same.
Okay, sorry. Anyway, how do you find an X intercept? Do you remember how to find that? Make y equal 0. Make y equal 0. So if y equals 0, what are you going to get?
2.
Yeah. 2 or...
-2 plus.
We did this. Did we solve absolute value equations? Awesome. When you're solving absolute value equations, what do you have to get by itself? The absolute value. So what do you do to both sides?
Add 2.
Add 2. So you're going to add 2. Wow, I thought this was 7th grade. I was like, how am I going to pull this out? All right. 2 equals the absolute value of x. So remember, you can come up with 2 little equations. X, and you could do this quickly, but this is the work. X is equal to +2, and x is equal to -2. It's both of them. And you're like, that's not possible. Let's look at it when we graph it. Remember, it's a V? But what happened to it? It got shifted down. So is it going to hit the x-axis only once? Or is it going to hit it now twice? Both of these are the X intercepts. 2 of them. 2 and -2. We're doing this tomorrow, by the way, guys. I'm not requiring you to do this on your homework yet.
For the y intercept?
Yeah.
Then we solve for that. Solve for 1.
You make what equals 0?
X.
So to find the y-intercept now, x equals 0. So 0 minus 2, -2, right?
Do you have to put 2 and -2? Or you
Both of them. And then your domain.
Infinity something.
Yes, infinity something, or something infinity.
Negative.
All right, you guys have already figured out our secret. What's the domain almost always going to be? Sorry.
Negative.
Yeah, negative infinity, positive infinity. Wow. I could do a lot better on that. Yay. Okay. It's possible. And then the range. Okay, look what happened here. The original graph, the parent function was like this, right? That's the parent. That's not that one. What did I say happened to this graph? It went It went down 2. 1, 2. Same graph, but it got shifted down. So guess what the new range is? Negative infinity, parenthesis, negative infinity, comma, negative 2, bracket. Yeah. All right. Negative infinity, comma, negative 2, brackets. Yay. I don't like this. Sorry?
Yeah, that's not right.
I don't like this.
Yeah, well, we
Yeah, because negative infinity is
No, you're right. You're good. Sorry. I got too ahead of myself. So, negative 2, positive infinity. Yes, you're correct. Thank you.
Wait,
All right. But, guys, what I'm going to do now is I've just been saying stuff, and you're like, well, I don't think that's even true. So let's just graph it real quick. Okay. It has a vertex of what? 0, negative 2. So right here. And I'll just go forward in every direction.
it would be going up.
Yes, because it's a positive. No negative sign. Okay. Where are the X intercepts according to what I said?
2 and negative 2.
So that means it hits positive 2 and negative 2 on the x-axis. It hits both. Like that? Is that even possible?
yes, because it goes down.
Okay, and you'll get graph paper tomorrow. Today you don't need graph paper, but you'll get graph paper. That's your graph. That's the V shape. And for some of you who want to see it more V, there you go. Okay. Is the domain negative infinity, positive infinity? Domain.
Yes.
Is the range, thank you for correcting me, is it stop at negative 2 and go into positive infinity? Yes, so that worked. And by the way, if I stood with mine, you know what would have happened? If you guys let me, you're like, I switched it around, I'm like, is it stop at negative 2 and go down? Oh, man. So you would have been able to check it. So thankfully, you checked it before I was able to. And, all right, is the axis of symmetry x equals 0? Does it cut it in half right here?
Yes.
Yep. So that's all true. I still don't believe it though. I'm a skeptic right now. Can you guys pick a point? Pick a point.
0, 0.
Okay, let's pick 0, 0. All right. 0 absolute value.
0.
Oh, 0, 0 is not a point. Oh, man, that's not even a point. What's this point?
2, 1. Pick 2, 1.
0, negative 2. Ah, all right. So do you see how 0, 0 is not a point? That's up here. All right. Sorry. What's the absolute value of 0? 0 minus 2. So if you get 0, what do you get for y? So right here. Pick another point.
Let's go with 2. Negative 2.
Is 2 negative 2 on the graph?
2, 0.
2, 0, right? 2, 0. All right. If x, absolute value of 2 is 2, what's 2 minus 2? Do we get that point? Do you guys see how you could check it? Okay, you don't need the graph in order to find those pieces of info, but I'm going to make you do the graph and the pieces of info. That's tomorrow night. Tonight, this is all I want you to do, and I'll finish out. I'm going to give you an equation like y is equal to absolute value of x minus 1. This is all I'm giving you tonight. And I want you to find, I'll make sure I say this, I want you to find the vertex.
That's it.
0, negative 1.
0, negative 1.
That's our homework?
Dude, don't show any work.
Sorry?
Don't show anyone.
Yeah, don't show work and get it wrong.
Yeah, see?
Don't be like your airball yesterday.
One time.
Yeah. Just to get it straight. Okay.
Great, no work.
Actually, guys, it does get a little trickier, so let me show you how to show your work. You want to make this equal 0. So how do I make this equal 0? What do I make x equal? All right? And what's the number outside?
Negative 1.
That's my vertex. Easy enough? Right? That's the work. But what about this one? Y is equal to the absolute value of x plus 7. This is where it gets a little bit, it's different. Same process.
Subtract.
Okay, what do I have to do to make this equal 0? What should x be?
0.
I heard it. One of you said it. Look at it, guys. This is the equation. X plus 7 needs to equal 0. So what does x equal? So x is going to be negative 7. And what's the number out here?
0.
Oh, wow. I didn't need that. That's the vertex. Let me give you another one. Yes, a tough one. Y is equal to x minus 25 minus 31. This is not hard homework, guys. This is very quick. All right.
Simplify.
First thing, listen up. I have to make this equal 0. So x minus 25 equal to 0. What does x have to be?
25.
Okay, that's your x coordinate. That's your x coordinate. Okay? And your y coordinate is whatever's outside. Negative 31. That's it.
How? What's our homework?
How did you
2 through 100.
Let's go!
Oh, you wanted to make this thing in here equal 0. So you just write that equation, solve it. Okay, I'm going to go with numbers 2 through
18. Number 2.
let's go 2 through 16 even. Not hard. It's just page 125. No, you don't need graph on this one. You're not graphing. You're just finding that vertex. Bye-bye, swivel.